Hi, let's look at greatest common factor. So let's look at some vocabulary first. Common factor. Well, if I'm looking at the number 6, the first thing I want to do is find all the factors of 6. So when I say all the factors, I want you to make this T chart. And then remember, start with 1. So 1 times 6 would give us 6. And then go to the next number, 2. Well, 2 times 3 gives us 6. And since the next number we would write would be a 3, and we've already written it, we're done. Okay, look at 12. If I want to find all the factors for 12, I want you to start with a T chart, and then start with 1 and 12, and then you would go to the number 2, 2 and 6, and then go to the number 3, 3 and 4. And since the next number you would write is a 4, and it's already here, you're done. Now when I say common factors, I mean what numbers are in both lists. So you see that 1 is in both lists, you see that 2 is in both lists, you see that 3 is in both lists, and you see that 6 is in both lists. So those are all the common factors, 1, 2, 3, and 6. Now when they ask you, well, what's the greatest common factor, now they want the biggest number that's in common in both lists. So I would have to say the greatest common factor of 6 and 12, of course, is the number 6, because that was the biggest number they had in common. Now the word's relatively prime. That's kind of cool. That means when you're comparing two numbers, let's say 8 and 15, that the only thing they have in common is 1. There's no other number that they have in common. And so you can see my list of factors for 8, and I want you to notice something. I did 8 times 1 would give me 8. 2 times 4 gives me 8, and then I wrote down a 3 because that'd be the next number. Well, there's nothing times 3 that would give me 8, so I cross it out. Then the next number I would write is a 4, and since I already see it, I'm done. Take a look at 15. I did 1 times 15, and then the next number I should try is 2, but there's nothing times 2 that would give me 15, so I cross it out. And then 3 times 5 gives me 15. And then I try 4, but nothing times 4 gives me 15, so I cross it out. The next number I would write is 5, and it's already there, so I know I'm done. But I want you to take a look and notice the only number they have in common is 1. So we would say the greatest common factor is 1, and any time that happens, we call that relatively prime in math. Now another way to look at it is you can use what you've learned before, factor trees. If I did a factor tree for 8, I would break it apart as 2 times 4, and then 2 is a prime, so I circle it. 4 is not, so I break that apart to 2 times 2. And so I would do the same thing with 15. I'd break it apart to 3 and 5. Now notice that there is nothing in common in the trees. The 15 doesn't have a 2, the 8 doesn't have a 5, so this we would say the only thing they have in common is that 1. So the greatest common factor is 1, which makes them relatively prime. Now let me show you another way to find the greatest common factor that's really great. And this is the way that I'll use more often. Let's say I want to find the greatest common factor of 54 and 81. So write 54 and write 81, and then I want you to do this upside down division house, okay? And then I want you to think of any number that you can think of that goes into 54 and into 81. Well, the first number I thought of was 9, and so I put a 9 out here, and then I do a little division. So 54 divided by 9 would give me 6, and 81 divided by 9 gives me 9. And now I want you to just look at the 6 and look at the 9 and do the same thing. Draw that upside down division house and ask yourself what number goes into 6 and into 9. And you should come up with 3. And now 6 divided by 3 gives me 2. 9 divided by 3 gives me 3. And when I look at the 2 and the 3, there's no factor they have in common except 1. So I'm done with the little division. But now look at this. The reason we do this is everything that forms this tower makes up our greatest common factor. Everything that's going up and down will be part of our greatest common factor. So you write greatest common factor equals, and then take the numbers 9, and then you have to put that multiplication symbol, and then put the 3. So 9 times 3 gives me 27. So 27 is the greatest common factor of 54 and 81. Let's try that again. Look at number 2. And this is really cool because it works with 3 numbers. So I'm going to put 12, 48, and 66. And I draw that upside down division house. And now the first number that I noticed that went into them is 2 because they're all even. So I put a 2 on the outside and then I divide. 12 divided by 2 gives me 6. 48 divided by 2 gives me 24. 66 divided by 2 gives me 33. And now I draw that upside down division house and I look at 6, 24, and 33. And I notice that 3 goes into all of them. So I put a 3 on the outside and I divide. 6 divided by 3 gives me 2. 24 divided by 3 gives me 8. 33 divided by 3 gives me 11. And now when you try 2, 8, and 11, there's nothing that goes into all 3 except the number 1. So this is where we stop. And remember, you can always see the greatest common factor. It's looking at you. It's straight up and down. It's the 2 and the 3. So I write the greatest common factor is 2 times 3, which is 6. So 6 is the greatest common factor of these 3 numbers. So now they want us to find the greatest common factor and they want us to tell if it's relatively prime. Okay, so let's do A over here. So I write 28 and 63, and I ask myself what goes into both, and I notice 7 does. So I put the 7 on the outside, and I divide. 28 divided by 7 gives me 4. 63 divided by 7 gives me 9. Now with the 4 and the 9, they have no common factors except 1, so I'm done dividing. And remember, the greatest common factor is looking at you right here. It's anything to the side. So the greatest common factor is 7. Now, if I get an answer of anything except 1, you would say they are not relatively prime. Okay, take a look at B. They want to compare 42 and 55. So this time I'm showing you the tree method because if you write it using the division method, you'd get stuck. You'd say nothing works. Well, look at 42. Before I say the relatively prime, I make a tree. So that's 6 times 7. I break apart the 6, 2, and 3. And then with 55, I break it apart, 5 and 11. Now look at the trees. They don't have any numbers in common. They're all different. That means the greatest common factor has to be 1, and these numbers are relatively prime. Okay, so let's practice some more finding the greatest common factor and deciding if they're relatively prime. So I take the numbers 30 and 49. Now, when I tried the division method, I couldn't think of anything. So I always make a tree if I feel stuck. So I broke apart 30 to be 6 times 5. 5 is a prime, so I circle it. Break apart 6 to be 2 times 3. With 49, I broke it apart to 7 times 7. Now notice the trees have nothing in common, so the greatest common factor is 1, and they're relatively prime. Take a look at number 4. So I wrote 52 and 78, and I did my upside down division because I saw they were even. So I took the 2 out, and I divided. That left me with 26 and 39. Now 26 and 39, those are a little bit tricky, but if you think about it, 13 goes into both of them. So I put a 13 on the outside and I divide. 26 divided by 13 is 2. 39 divided by 13 is 3. Now with 2 and 3, we're done because they have nothing in common except 1. And remember, the greatest common factor is looking at me right here on the side. So the greatest common factor is 2 times 13, which is 26. Since the greatest common factor was a number other than 1, that means these are not relatively prime. Okay, let's find the greatest common factor of monomials. Now this is cool. This is algebra. So take a look at the first monomial. It's 12x cubed. So what I always recommend is the tree method to get started. So let's break it apart, and we separate the 12 from the x to the third power. Now 12 breaks apart to 2 times 6, I circle the 2. 6 breaks apart to 2 times 3, and I circle the 2 and the 3 because they're primes. Now with x to the third power, you guys know that means x times x times x. Okay, look at 18x squared. So I separate the numbers from the variables. So I put the 18 and the x to the second power. Now I break apart 18, 2 times 9. I break apart 9, 3 times 3. And then I break apart x to the second power times x times x. Now, the way that we can find the greatest common factor is we just find everything they have in common. So notice that both trees have a 2, so I put 2 in my greatest common factor. Both trees have a 3, so I put 3 in my greatest common factor. And both trees have 2 x's, so I put 2 x's. And then I just multiplied. 2 times 3 is 6, x times x is x squared. So the greatest common factor is 6x squared. Now look at number 6. I showed you another method. This is the division method. So when you use the division method, I want you to write out the variables. So notice I wrote 40 and then x times y times y times y. I wrote it out. And then 24 times x times y. The first thing is start with just the numbers. Ignore the letters. So 40 and 24. I noticed that 4 goes into both. So I put a 4 on the outside and I divided. And I got 10, and I bring down the x and I bring down the y's. And I got 6, and I bring down the x and the y. And now with 10 and 6, I notice that 2 goes into both. So I divided. I got 5, and I bring down the x and the y's. And I got 6 divided by 2 is 3, and I bring down the x and the y. And now I notice, since the numbers, I can't go any farther, 5 and 3, I'm done with those. Now I'm going to circle the x's. See how they have an x in common? So I circle what they have in common, and I pull it to the outside here. I put it outside. And so now I have 5, and then I bring down the y's, and I have 3, and I bring down the y. And now I notice that they have 1 y in common, so I circle it and bring it to the outside. And now I bring down 5, y, and the 3. And notice on the bottom there's nothing else they have in common, so I'm done. And I look on the side, and that's my greatest common factor. It's staring at me. So the greatest common factor is 4 times 2 times x, which I simplify as 8xy.